In this short video, I'd like to look at some common pitfalls in the use of quantifiers in people that are very new to first-order logic. So first-order logic, we have two standard quantifiers, the universal quantifier and the existential quantifier. And I want to give you two general guidelines that will hopefully help you write formulas more effectively and not make two very common mistakes. So universally quantified variables belong in a rule or an implication, and existentially quantified variables that are not in on a negated atom should not appear in the antecedent or the if part of a rule or implication. Right? So I want to explain what I mean by these two rules. So universally quantified variables belong in a rule. Why is that the case? Let's just take an example. All dogs like all cats. Now, a very common sort of mistake is for people to write something like this first formula. For all x and all y, x is a dog, y is a cat, and x likes y. But keep in mind that when we have a conjunction, that conjunction is separable, right? Each of these things are things that we're saying individually as well as collectively. If it's in a conjunction, we're saying this is true, and this other thing is true, and this third thing is true. So we're saying it's true that x is a dog for all x. It's true that cat is a y for all y, etc. So let's make this a little more concrete. Let's say we have a universe with just three entities in it: Fido, Fluffy, and Bob. And Fido's a dog, Fluffy's a cat, and Bob's a human. So if we say this incorrect sentence, we are saying, among other things, individually, that for all x, x is a dog. Well, given our universe, then that means we're asserting that Bob is a dog, and so is Fluffy, and that's counter to what our universe actually is intended to say. So the formula here, as stated, is incorrect because it allows you to reach incorrect conclusions, conclusions that are inconsistent with how you really want to formalize this particular world. So what's the correct way to do this? Well, the correct way is to put it into a rule. That's what you actually mean here. If we're saying all dogs like all cats, that means really for all x and y, if x is a dog and if y is a cat, then x likes y. Right? So for every dog and every cat, the dog likes the cat. We have only one possible conclusion for our particular universe. So we're going to do first order resolution here. That involves unification. So we're going to unify our previous statement that Fido is a dog, dog of Fido. If we unify that with dog of x in our rule, we get the following sigma or substitution. X gets the value of Fido. We only have one assertion with a cat in our knowledge base. So cat Fluffy unifies with cat x. Therefore, the substitution, sigma, is that Fluffy gets the value of y. We then apply this unification across the entire formula to get likes Fido Fluffy. And notice that we never make any conclusions about Bob. He's just not in the picture. Bob is a human. He's not a dog or a cat. And so we don't get any fake assertions, incorrect assertions about Bob being a dog, or for that matter, Fluffy being a dog. Right? The formula as stated now, the correct version, gives us the result we want in practice. It says what we intend to say about this universe. And that's why we want universal quantifiers to be in rules. Let's look at existential quantifiers. So existentially quantified variables, unless they're in a negated atom, because remember this general equivalence, right? That if we have, for all x, not something of x, is the same as there does not exist an x such that something is true of x. Okay, so the negation flips the quantifier. But if we don't have this negated quantifier, then I want to explain why this is a problem. So let's take three different possibilities for encoding the short English sentence, apples are delicious. For all x, apple of x implies delicious of x. There exists x such that apple of x implies delicious of x, or there exists x such that apple x and delicious x. And one of these I would say is clearly correct, and the other two are not. And I've seen students generate all of them. So let's look at why they might be correct or incorrect. So let's take a look at what are some models of the following formulas. Right? If we have apple 1 is an apple and apple 1 is delicious, that's going to be a reasonable model for all of the formulas that we've stated here, right? If we only have one apple in the world, then for all apples are delicious. There exists an apple, and that apple entails that it's also delicious. And there also exists an apple that is delicious. If you can do the first order resolution along with unification, you'll find that these are in fact all true. Let's take a different world in which we just have pairs. So we have asserted that pair 1 is not an apple, but it is also delicious. That is going to be a model of the first case, actually. Right? That if x is an apple, then it's delicious. It's going to be a model of the second rule, that there exists an apple that is delicious, and if you reduce this to conjunctive normal form, you can prove that it's true. I'd encourage you to do that with a modern first order theorem prover like E or Vampire. And the third world here, world C, apple 1 is an apple and it's not delicious. Well, that's not a model of any of these formulas, and it's really the last case that shows why this is problematic. Let's see, we have an apple that is delicious and an apple that's not delicious. And that world violates the first case, but not the other two, right? Here we have an apple that isn't delicious, right? It's contradicting apples are delicious. We'd expect this not to work, and yet rules 2 and 3 allow this to be true. And that's clearly not in line with how most of us, I presume, would understand these English sentences, right? So that's why versions 2 and 3 are not correct. They don't mean what normal English reader would interpret that to mean. We really are saying, when we say apples are delicious, we're saying if X is an apple, then it's delicious, and that holds for all apples. Okay, so I hope this gave you a little explanation and hopefully some intuition on how to write formulas with quantifiers a little better and not make these common mistakes.